Welcome to the next optimization problem. A closed box with a square base is to have a volume of 2,000 cubic inches. The material for the top and bottom of the box is to cost $3 per square inch, and the material for the sides is to cost $1.50 per square inch. If the cost of the material is to be the least, so we want to minimize the cost, find the dimensions of the box, right? So our goal is to minimize the cost. You minimize the cost by minimizing the surface area. Right? This is a closed box with a square base. Right? So it's drawn over there. Right? So the base is going to be the side, right? Because it's a square base, and we know a square, all four sides are exactly the same. And then we have another dimension as a height, and we don't know how much that height is. Right? So let's write down all the sides that we have. This box has 6 sides, right? Right. So, and then we have to consider how much the box costs. Right? All the different sides cost. All right. So let's first of all figure out surface area of this box. All right. So it's got 2 sides that are the bases, right? So right there. Those two. This side and the one you can't see are the exact same thing, right? Opposite sides on a rectangular prism are going to be the same, right? So we've got x squared, right? And we got 2 of those, right? 2x squared. Right? And then we have 2 sides that represent the front and back here. Right? And actually, well, try and turn the box over. The top and bottom are the x, right? Because the top and bottom has a square base, all right? So this is the top right there, and the bottom you can't see. So we have sides, right? So this is one set of sides, the front and back here. And so that would be x times y, and there's 2 of them, so plus 2 times x times y. And then there's the other pair of sides, right? Which would be right here. And lo and behold, they're the exact same thing, right? Because this is a square base, right? So instead of writing 2xy, let's write 4xy. All right, so then we have this secondary equation, and that is to eliminate a variable taking into account constraints. And that secondary equation is the volume, right? Because it has to have a certain volume, right? So we make the box super, super tiny. We'll use less material, but then it won't have a volume of 2,000 cubic inches. Right? So our volume is 2,000 cubic inches. Also, we have to consider the price of the top and the bottom because the top and the bottom costs more. Right? So top and bottom, $3 per square inch. This must be made of something really impressive. The sides cost $1.50 per square inch. Right? So the total cost is going to be the base area plus the times the cost, $3, plus the lateral area times the cost, which is $1.50. All right, so now let's use our secondary equation to get rid of one of our variables. And who should we get rid of? Well, it is the y. And you'll see why right away. Right? So the volume of any rectangular prism is base times the height. We know the base of the prism, the top and the bottom. Let me put a T there for top and bottom. Let me put a B for base. And actually, let me write in a color that you can actually maybe see. So right here, that is our base. Right? So we can represent that with x squared. We can also replace volume, right? Because that's 2,000. So we'll replace the volume with 2,000. We'll replace b with x squared, and we'll replace height with y, right? Because that's the height. If we divide both sides by x squared, right, we will have an expression that we can replace the y with. Of course, right away you should recognize you need to replace the y because there's only one of them and there's a lot more x's. So y would be easy to replace. So y is equal to 2,000 divided by x squared. And if we replace the y with 2,000 x squared and then multiply it by the cost, we will have our new equation. So the new equation our new equation, which I'm going to put right here. I'm going to put S for surface area. So I'll put S of x for surface area equals 2x squared times, that costs $3, right? Because this is the base and this is the lateral area. So times 3. That's a 3. And I'll have to put the 0.00 in. Don't have to put the dollars in until later on if we need to. It doesn't, and it actually doesn't ask for cost, it just asks for the dimensions. So 3 is fine. And then plus 4x, we'll replace the y with 2,000 divided by x squared. And then we'll multiply times the cost, which is 1.5 for $1.50. Or, all right, 1.50 for $1.50. Let's simplify. Oops. Well, looks like I didn't erase everything. I'm going to erase everything because I wanted to write it nicer. But I was just moving the screen down because I needed a tad more space. When I extend the page, I can't always see that there's writing below. All right, so let's simplify this. S of x equals 6x squared plus, so that would give us 4 times 1.5 is going to be 6. And then the x's will cancel, right? So that would be 6 divided by x. Right? Let's just write that as x to the negative 1, right? Because we're going to have to do that anyway when we go to take the derivative. Right? So, oh, whoops, I forgot to multiply by the 2,000. Oh, never mind. 6 times 2,000 would be 12,000 over x. I'll just write it like that, and then I'll simplify it. S of x equals 6x squared plus 12,000 x to the negative 1. Now we can take the derivative, right, and find the critical point. All right, so that would be s prime of x equals 12x minus, and that would be 12,000 x to the negative 2. We'll simplify that negative exponent, set it equal to 0. So 0 equals 12x minus 12,000 divided by x squared. You can, once we change that to a proportion, we can simplify. So we have 12,000 divided by x squared equals 12x. And I like to put it over 1. Just, I don't know. It looks nice to me. We can reduce the coefficients in a proportion. So this would be 1,000. Right, and that would be 1. So now we'll just cross multiply. Oh, that's a nice easy solve. Not like that can problem where we had a cube root of a really weird number. All right, so we have 1,000 equals x cubed. We'll take the cube root of both sides. All right, so I'm going to switch the x over here. Man, I don't know what's going with this. That looks like a backwards 9 instead of being all persnickety. Look at that, it's way off. There we go. X equals 10. That would be the cube root of 1,000. All right, so now let's do a sign chart. And let's do that over here. How many times is board tool is going to pop over on that side there? Maybe if I move it over. All right, so sign chart, we've got 10. That's better. That was our critical point, and we need to check something less than 10 and more than 10. How about 1 and 11? That would be nice. All right, We plug that into the derivative, which is, I'm going to plug it into the simplified one but ignore the 0. So that would be 12 minus 12,000. All right, so clearly negative. And if we plug in 11, 12 times 11, 132. 12,000 divided by 11 squared would be 12,000 divided by 121, which is 99, right? And 12,000 divided by, where was it? No, so excuse me, 12, just 12 times 11. So 132 is definitely greater than 99. So 132 minus 99 something is definitely going to be a positive number. All right, so not x, oh yeah, it is x. X equals 10 is a relative minimum because we've got a random line here. And I'm going to actually write because s prime of x changes sign from negative to positive at x equals 10. All right, so we've justified that. Always want to justify it. All right, and then let us find the second derivative. Take the second derivative. To verify solution, or verify critical point. Critical point / solution. All right, so we have s double prime of x equals, so this would be 12 plus 12,000 x to the negative 3, right? But those are all positive numbers, right? So since s double prime of 10 is greater than 0, s of x is concave up at x equals 10, verifying that x equals 10 is a relative minimum. Up, it's at the bottom. Now all we need to do is answer the question, and that was to find the dimensions. And I can see the y right there. We've already got x. If I can just move my screen down, there we go. So the dimensions that minimize the cost of the rectangular prism box is let's call it x, the base measurement. So a base measure of 10 for the square base. I think when I do these, I say this differently every single time. And a height of let's plug it into y, and oh, now I can't see y after I moved the screen down. Y was, see at the top of the page, 2,000 divided by x squared. Oh, that's a, oh, these are such pretty numbers. Such pretty numbers. Whoops, sorry. That's the YouTube screen that I use to post the videos on. All right, so I'm going to extend it just a little bit. So y equal, obviously the board has no concept of extend it a little bit. Come on, the people want me to finish this video. Don't move again. I'll plug it over here. Of y equals 2,000 divided by 10 squared, or 20, I think it was in centimeters. Let's put in the units, sorry. Make that 10 centimeters. Right, because wasn't it 2,000 centimeters for the volume, or 20 centimeters. All right, so that's going to be the height of the rectangular prism. All right, and that finishes off this problem. Thanks for watching. Have a great day, and bye for now.